Section 7.5, adding and subtracting rational expressions. Okay. Okay. So let's recall, say if you had 3/8 plus 1/8. If you had a common denominator, you just add numerators. 3 plus 1, 4 over 8, and keep the same common denominator. If you can reduce this, you would reduce this. And similarly, if you have two fractions with the same common denominator and you're subtracting, you subtract numerators and write it all over the common denominator and reduce it if at all possible. Now, if you have let's say 1/3. Suppose you have you want to add two fractions with where they don't have common denominators. Well, you find the common denominator, rewrite each of your fractions as equivalent fractions with the same common denominator. So you would multiply by 1 so that you can rewrite them as equivalent rational fractions with the same common denominator. And then add, just like what you did in the previous example, and reduce if at all possible. So let's do some examples. On page 286, let's say problem number 2. 3 over y plus 4 over y. In exercises 1 through 10, add the rational expressions with like denominators. Write your answer in those terms. And so, well, I have a common denominator of y, so let's add numerators. 4 plus 3 is 7 over y. And that is your answer. Let me do problem number 8. 4x plus 3 over 2x minus 7 plus 3x minus 8 over 2x minus 7. And so, since I have a common denominator, I'll add numerators and write them all over the common denominator. So 4x plus 3x is 7x. 3 minus 8 is minus 5. And so I am done. Let me do problem number 12. X over 10 plus 2 over 15. Okay, so in exercises 11 through 29, add the rational expressions with different denominators. So in this case, the least common denominator is 30. So let me multiply and divide by 3, by 2. And so I get here 3x plus 4. Each of these are all over 30, and so I can add numerators, 3x plus 4 over 30. And that is my sum. Let me do problem number 20. 4 over x plus 4 plus x. And so let me rewrite x as x over 1. The least common denominator in this case is x times x plus 4. I'm sorry. The least common denominator in this case is x plus 4. And so I'll just multiply and divide by 1 for this first term by x plus 4 for the second. And so I get 4 over x plus 4, and then x squared plus 4x. And so I can add numerators, x squared plus 4x plus 4, all over the common denominator, x plus 4. I'm done, but I could actually write the numerator, x squared plus 4x plus 4, as well. This is a perfect square trinomial. X squared plus, well, x times 2 is 4x, plus 2 squared is 4. And well, there's nothing in common between numerator and denominator. So you can write it either way, and both of them are 100% correct. It's best, of course, if you factor as much as possible, just to be sure that there's no factors in common between the numerator and denominator. Let me do problem number 28. 2a over 4a squared minus 9b squared plus 1 over 2a minus 3b. So let me factor. Well, the denominator factors in 2a minus 3b and 2a plus 3b. This is a perfect, it is the difference of squares, so I can factor it. And, well, you really can't do anything with that. So the least common denominator in this case is just 2a minus 3b times 2a plus 3b. So let me multiply and divide this first by 1, the second fraction by 2a plus 3b. And so you get 2a in the numerator and 2a plus 3b in the numerator. So let's add. And I have as my common denominator 2a minus 3b times 2a plus 3b. 2a plus 2a is 4a plus 3b. And I am done. Let me do problem number 40. Actually, let's see, we're at 28. Yeah. So let me do problem number 34. 34. Two x, 2 over x, minus 5 over x. In exercises 30 through 55, subtract the rational expressions. So I have a common denominator of x, subtract numerators. 2 minus 5 is a negative 3. And that is your answer. Let me do problem number 36. Y squared over y to the fourth plus 1 minus 1 over y to the fourth plus 1. So I have a least common denominator of y to the fourth plus 1. And what remains is, and the numerator I can subtract. I get y squared minus 1. Now you can factor the numerator if you wanted, but there are no common factors between the numerator and the denominator. So I can just leave it in that form, mostly because I don't have any more room left. Let me do problem number 44. 2 over 3 minus x minus 4 over x minus 3. Let me rewrite this. I guess what I'll do is I'll rewrite it so notice I have a 3 minus x and x minus 3. And so I can actually, these two denominators are really the same. The only difference is the order. One I wrote x minus 3, the other I wrote 3 minus x. Well, if you recall, you can change the order as long as you take whatever sign is here, which is the minus sign, and multiply it by whatever is here, another minus. And so that would make it a plus. So actually, that's the same as 2 over 3 minus x. Minus and a minus make that a plus 4 over 3 minus x. And now add numerators. So now we have a common denominator, 3 minus x. Add numerators, 2 plus 4 is 6. And I'm done. Let me do, let's say problem number 48. So this will be somewhat similar. So problem 48, 3 over a minus 6, a plus 6, minus 2 over 6 minus a. So I notice here in this second term here, I have 2 over 6 minus a. Let me change the 6 minus a and let me rewrite it as a minus 6. When I do that, this minus sign makes that subtraction an addition. And so I see that the least common denominator is a minus 6, a plus 6. So let me do that. And so let me multiply and divide this first by 1. Oops. So let's multiply. Oops. Let's multiply and divide by 1. Multiply and divide by a plus 6. And let's multiply the 2 inside the parentheses. So I get 3, 2a plus 12. And so my least common I have a common denominator, so I'll just write the common denominator and add numerators. 2a, 3 plus 12 is 15, and I am done. Let me do problem number 54. 1 over x minus y minus 2y over x minus y, x plus y. And so we can see that the least common denominator in this case is x minus y times x plus y. So let me multiply this first fraction by x plus y and divide by x plus y to get an equivalent rational expression with the same common denominator. Here you just have to multiply and divide by 1. And so you get x plus y minus 2y. So multiply and divide by 1. And so I have a common denominator, x minus y, x plus y. And I have here x plus y minus 2y is minus y. The x minus y's cancel. And so you just have 1 over x plus y. And that is your answer. Let me do problem number 58. X, 1 minus x, plus 1 over x minus 1. So let me rewrite this. 1 as 1 over 1. So the least common denominator here is x times 1 minus x. Let me multiply and divide by x, 1 minus x, x times 1 minus x, which is just the same as x squared minus x. And so let me multiply the negative 1 inside the parentheses. So I have here x squared. 1 times 1 minus x is 1 minus x. I'm multiplying in the negative sign, so this will become a plus. Negative x squared plus x. So let's add each of these fractions and write them all over the common denominator, x 1 minus x. So I have here x squared minus x squared, so those cancel. I have here negative x plus x, that cancels. So all that remains is a 1. And that is your answer. Let me do problem number 64. Three x minus 1 plus 4 over x squared minus 1 minus 5 over 1 plus x. And so this is 3 over x minus 1 plus, let's factor, x squared minus 1 is the difference of squares. So by the special product formula, special factoring formula, factors into x minus 1, x plus 1, minus 1 plus x is the same as x plus 1. The only difference is the order. So let me rewrite it as 5 over x plus 1. And since there's a plus in the middle, I'll multiply positive times negative, gives me negative. So that subtraction remains the same. The least common denominator in this case is x minus 1, x plus 1. And so I need to multiply and divide by the same quantity so that I can find equivalent fractions with the same least common denominator, x minus 1, x plus 1. So let me multiply this first fraction by x plus 1 over x plus 1. Here I just have to multiply and divide by 1. Here I have to multiply and divide by x minus 1. Let me multiply 3 inside the parentheses. I guess in this case I'll just multiply 5 inside the parentheses rather than negative 5. And so here I actually multiplied, I included the negative. Here I won't include the negative. So I have here 3x plus 3. 4 times 1 is just 4, minus 5x minus 5. Okay, so now I have the same common denominator. Add my denominators, my numerators. 3x minus 5x is a negative 2x. 3 plus 4 is 7. Minus a negative 5, same as plus 5. So that's 12. And I'm done. But I could actually factor out a negative 2 for the numerator. But it's not going to make any difference because once I factor that out, I get x minus 6, which you still cannot cancel with anything in the denominator. So either of these answers is completely correct. Let me do problem number 70. Two over 3x plus 3 over x squared minus 1 minus 5x over x plus 1. So let's factor. It's 2 over 3x. It's 3 over factor. There's a difference square, so x minus 1, x plus 1, minus 5x over x plus 1. So the least common denominator is going to be 3x, x minus 1, x plus 1. And so, see if I can write this. 3x, x minus 1, x plus 1. Okay, so let me multiply and divide by x minus 1, x plus 1, which is the same as x squared minus 1. Multiply and divide by, I guess, 3x. Here I'm going to have to multiply and divide by 3x, x minus 1, which is the same as 3x squared minus 3x. So let me multiply a 2 inside the parentheses. Multiply these together, and I guess I'll do the 5x. So I get here 2x squared minus 2, 9, and then 15x squared cubed, that's a cube, minus 15x squared. So this is equal to well, I have a common denominator, so let me write these all over the common denominator. And now let me add all these. numerators. So I get a negative 15x cubed, 2x squared minus a negative 15x squared, same as 2x squared plus 15x squared, 17x squared, minus 2 plus 9 is plus 7. And that is your answer. Let me do problem number 80. One over a minus b minus 1 over a plus b 1 over a squared minus b squared. So I have here a minus outside the parentheses. So let me change all the signs inside the parentheses. So this becomes 1 over minus 1 over a plus b. Minus and minus become a plus 1 over a squared minus b, which I can factor as a minus, it's the difference of squares. So I can write this as a minus b times a plus b. So I have a least common denominator of a minus b, a plus b. And so, oops, let me rewrite each of these rational expressions as equivalent rational expressions with the same least common denominator. So let me multiply and divide by a plus b by a minus b by 1. Hmm. Okay, let's see if I can. Yeah, good enough. Okay, so I get here a plus b. I'm just going to multiply by positive 1. So a minus b and 1. So let's add everything. So I have the least common denominator, a minus b, a plus b. A minus a cancels, so the a's cancel. B minus a negative b is same as b plus b, so I get 2b plus, well, in this case, 1. And that is your answer. Okay. Let's see if there are any more questions here. Oh, that's it for this section. Okay, so that's it. That's it for this section.